Ladies and gentlemen, please rise for the procession of the Slovak Academy of Sciences. Good morning. It is an honor and privilege to welcome you on behalf of the President of the Slovak Academy of Sciences, Professor Pavla Šajgalík, here at the Hall of Mirrors at the Primacial Palace for the award ceremony for the 2024 International Prize of the Slovak Academy of Sciences, which will be awarded for achievements in technical sciences. My name is Tomáš Hromadka. I represent the Academy, and I will also be your guide during the ceremony with all these gadgets that they put on me, and all these blinking lights. And I'm especially grateful I can welcome all our distinguished guests. Professor Miroslav Zeman from the Delft University of Technology. Your Excellencies, ambassadors, Head of European Commission representation in Slovakia, state secretaries, representatives of embassies in Slovakia, distinguished representatives of Slovak universities, Slovak Rectors Conference, and the Polish Academy of Sciences, representatives of the Ministry of Education, Research, Development, and Youth of the Slovak Republic, and of course, members of the Assembly, the Scientific Council, the Presidium, and the Council of Directors of the Slovak Academy of Sciences, members of the Learned Society of Slovakia. Ladies and gentlemen, dear friends and colleagues, the ceremony usually begins with the mention of historical significance of this room, in which the Peace of Pressburg was signed after the Battle of Austerlitz in 1805. As significant as the event was, it's very obviously unrelated to this ceremony. We are here today to add another, different chapter to the book of historical significance of this very room. We are here today to celebrate science, and we are here today to recognize exceptional scientific achievements of an outstanding scholar who will be awarded the 2024 International Prize of Slovak Academy of Sciences. And we shall begin the award ceremony itself with music. We are very fortunate to have with us here today the Mucha Quartet, an internationally acclaimed string quartet Having received the nomination from the Embassy of the Kingdom of the Netherlands in Slovakia, the Scientific Council of the Slovak Academy of Sciences, in recognition of outstanding work related to Slovakia, awards the 2024 International Prize of the Slovak Academy of Sciences in Technical Sciences to Professor Miroslav Zeman from the Delft University of Technology. Now I would like to ask Professor Petr Samuely, our Vice President for Science, Research and Innovations, to deliver a laudation for Professor Zeman. Please, Professor Samuely.
Excellencies, President of the Slovak Academy of Sciences, spectaculars, ladies and gentlemen, the universe is mostly energy. The enigmatic dark energy responsible for the accelerating expansion of the universe dominates. It makes some 68% of the total energy. In the observable universe, the dark matter contributes 27% and ordinary baryonic matter only 5%. But even ordinary matter mostly converts into energy when stars are burning in nuclear fusion, fusing hydrogen atoms into helium. And photons bring the energy of the sun to the earth as the most important prerequisite of life. Mastering, control, and converting energy is the key to rule the world. We know that this ability did not come just like that. It was brought by a divine Prometheus who stole a skill to use the fire from gods and gave it to humans and commenced the civilization. Yet, few thousand years later, the energy and its conversion is the civilization major challenge. Yet it's also a whole life challenge of our awardee, Professor Miroslav Zeman. Professor Dr. Engineer Miroslav Zeman is a proper Slovak pronunciation, studied electrical engineering at the Slovak University of Technology in Bratislava, carried out his PhD there, and in 1989 he became a research fellow at the Delft University of Technology. In 2008 he became a full professor of photovoltaic materials and devices in the Department of Electrical Sustainable Energy, and in 2011 the head of this department. In 2019 he was appointed Knight in the Order of the Netherlands Lion by His Majesty Willem-Alexander, the King of the Netherlands, for his scientific contribution to building a sustainable society. On the occasion of the 30th anniversary of the Slovak Republic, the President of the Slovak Republic, Mrs. Zuzana Čaputová, awarded him with the State Order of the Ľudovít Štúr. Miroslav Zeman is a pioneer in the area of light management of thin film solar cells. He was studying and demonstrating light trapping techniques since 1990, especially light trapping based on scattering of light at rough interfaces. His concept of modulated surface texture demonstrated a world record initial conversion efficiency of 15% for a double junction thin film silicon solar cell, later 24%, and today world's record of 27% by a Chinese company Longi uses the architecture introduced by him. Professor Zeman is an expert in modeling in semiconductor devices with the focus on solar cells. He developed the software package used by more than 30 research groups all over the world. In addition, he successfully carried out research on new concepts for solar cells based on plasmonics, quantum dots, and photonic nanostructures. More recently, he started research on a large-scale implementation of the photovoltaic technology into society, especially in the urban environment, and established the Electrical Sustainable Power Laboratory, integrating new technologies into electricity grid. Recently, he has started an energy hub for residential energy communities where solar electricity is stored in a battery and hydrogen. The energy hub has been built on the campus of the Delft University of Technology, and it's in operation. Professor Zeman has published more than 300 research papers with more than 15,000 quotations and supervised more than 40 PhD completed theses. Now about successful cooperation between the Delft group of Professor Zeman and the Slovak Academy of Sciences and Slovakia in general. It started already in 1998 in a very unusual way, which we would like to see more often from the point of view of the Slovak Academy of Sciences, when Technical University of Delft purchased the deep-level transition spectroscopy measurement system developed by Dr. Turzo from the Institute of Physics of the Slovak Academy of Sciences. The spectrometer was applied in investigations of electronic properties of thin amorphous silicon layers, which are used in solar cells and flat panel displays. That time, one of the research priorities of the Technical University of Delft. The equipment offered an important additional information about the quality of amorphous silicon implemented in solar cells and thin film transistors. The cooperation continued by Dr. Nádaždy, I think present here, from Institute of Physics, and was presented at the top international conferences, and different aspects of defect states distribution in amorphous silicon was described in a number of joint publications, as in Physical Review B, Applied Physics Letters, and so on and so on. Dr. Nádaždy was the first researcher in the group of Professor Zeman who fabricated an amorphous silicon solar cell with efficiency above 10%, which was at that time a top world achievement. The experience gained from this period was invaluable in introducing organic and perovskite solar cell research in the Institute of Physics of the Slovak Academy of Sciences. Professor Zeman became also a co-founder of the Slovak Renewable Energy Agency in 2006. He also joined the advisory board of the Advanced Material Application Center, cena, of the Slovak Academy of Sciences, and acted as an international expert in the International Center of Excellence for Research into Intelligent and Security Information and Communication Technologies in Slovakia. Ladies and gentlemen, due to invaluable contribution of Professor Zeman to the advancement of the world, science and engineering, and because of his long-term links to the Slovak science and engineering, the Scientific Board of the Slovak Academy of Sciences has decided to recognize his effort by the International Award of the Slovak Academy of Sciences. Congratulations. Thank you.
I would like to ask the President of the Academy, Professor Pavla Šajgalík, to present the 2024 International Prize of the Slovak Academy of Sciences in Technical Sciences to Professor Miroslav Zeman.
Vždy padne, nie? Môžem po slovensky, nie?
Môžete, jasne.
Dovoľte, aby som odovzdal teda túto cenu, ktorú pripravila Slovenská akadémia vied pre mimoriadne úspechy vo vede v medzinárodnom meradle a teda vy si ju právom zaslúžite. Takže ďakujem veľmi pekne.
Ďakujem veľmi pekne.
So now, as the award has been semi-safely stored on the table, I'll just put it back. I would like to point out that the award itself has been designed by Marian Lašák from the Academy of Fine Arts and Design and produced by our very own Institute of Materials and Machine Mechanics under the supervision of František Simančík, himself a member of the Presidium of the Academy. So, as the award has been handed over, I would like to ask Professor Zeman to deliver his 2024 International Prize Lecture. Professor, the floor is now yours.
Mr. Chairman, thank you very much for nice and Professor Samuelyho extended introduction. I don't know whether I need to show you any presentation because everything has been already said. But before I give my address in English, because it's an international prize, I would like to say some sentences in Slovak. Vážené dámy, vážení páni, je pre mňa veľkou cťou prebrať si Medzinárodnú cenu Slovenskej akadémie vied v oblasti technických vied. V mojom prípade ide o rozvoj tzv. Fotovoltickej technológie, technológia, ktorá umožňuje premenu slnečného žiarenia priamo na elektrickú. Čo by som vlastne chcel po slovensky povedať je, že asi pred 60 rokmi ja som na tomto historickom mieste, asi 100 metrov odtiaľto, získal moje základné vzdelanie na základnej škole na Nedbalovej ulici. A teraz po takmer 60 rokoch mám možnosť s vami, s predstaviteľmi vedeckej komunity, umeleckej komunity, spoločenskej komunity podeliť sa s mojimi poznatkami a skúsenosťami. Pre mňa určite je dnes výnimočný deň, nielen v mojej kariére, ale aj v živote. A preto by som chcel poďakovať ľuďom z veľvyslanectva slovenského v Hágu, že ma navrhli na toto ocenenie, odbornej komisii, ktorá ma vybrala ako jedného z kandidátov a nakoniec Vedeckej rade Slovenskej akadémie vied, ktorá mi cenu udelila. No a keďže sa jedná o medzinárodnú cenu, ja svoju prezentáciu, svoj príhovor urobím v angličtine. So, ladies and gentlemen, my talk today is about affordable electricity from solar energy converted by a photovoltaic technology. Affordable electricity from the sun was only a few years ago just a distant dream. Today, the photovoltaic technology delivers the cheapest electricity in many parts of the world. And I was fortunate that I could work on the development of this technology. And when I look back at my career, I call it a journey to the sun. And I would like to acknowledge the Technical University in Delft, several international scientific institutions, including Slovak Academy of Sciences, and also friends and family members and Magda, my partner, that accompanied me on this journey. And today I am going to take you with me on this journey to the sun. It has become usual that at the beginning of such a speech you see photographs or short videos of situations that can lead to colossal disasters. These are to justify research and scientific work to look for the solutions to avoid these extreme phenomena. I also start with a video, but it will not show any tense or terrifying situation. On the contrary, it will be completely different. So now you are probably asking why he showed us this video. And to be really honest, my feeling is that in last years, the world has become very fast and superficial. And many phenomena and things we take for granted, and we do not stay still at their importance and meaning. A sunrise is such an example. When did you, in the last time, consciously watch sunrise? Oh, fantastic. And have you ever thought about the power of this energy source? For me, sunrise is a magical moment when part of the earth is flooded by light of enormous energy. The sun is the donor of life on the earth, but there is still a plenty of solar energy that we people can utilize. So energy has become a very important societal topic. But what is energy exactly? In our daily life, we relate energy to electricity that we use to power our household appliances, to petrol to drive our cars, or gas for heating and cooking. These forms of energy we call useful energy. And I can imagine that I know that many people really do not care where this energy, useful energy, comes from. Maybe it is also your case. But don't worry, some time ago I was also like that. But you can imagine that there are people who monitor which useful energies we consume, where do they come from. And the energy sources where they come from we call primary energy sources. And there are even scientists that look and study what are the reserves of these primary energy sources, or in other words, how long can we people use them. And in the next two slides, I would like to show you what are these primary energy sources and what can we do with it. And from the perspective of human civilization, we can divide the primary energy sources in two groups. The first one is infinite energy sources. We call them also renewable energy sources. And the second group is finite energy sources. So let's have a look to these infinite sources. You see that solar energy has really enormous potential. But to compare the potential of these infinite energy sources, I took as a reference global annual consumption we have in the world, and the size of this red circle actually represents the amount of this power. And as you can see, the amount of solar power that is incident only on land of our Earth is more than 1,000 times bigger. From the other renewable energy sources, wind energy can play a significant role in the mix of primary energy sources in the future. Now let's turn our attention to finite sources, and you see that the biggest finite primary energy source is coal. And to understand for how long or how quickly we can deplete these sources, I took as a reference life expectancy of people living in our European Union. And this life expectancy is 75 years. And when you look at the sources of finite sources, then you can see that when we take only a coal as our primary energy source and nothing else, and consume it with this power that we need for fulfilling our energy requirements, then this primary energy source is good enough for 41 years. With gas, oil, and nuclear, when we bring all these finite primary energy sources in our energy mix and use it, then the total number of years that we have these sources available is 79 years. So when you compare it to the European person life expectancy, people who, or children that are born today, at the end of their life, they do not know what coal or gas or oil was. So I think that these two slides make it clear what the availability of energy sources is. And you see that we must switch to renewables. And there are valid and serious arguments for that. Climate change, global warming, air pollution, nature destruction, just a few of them. But for me personally, the argument for switching to solar energy is very simple. It is the largest primary energy source that we people have available, and we have technology to utilize it, so let's do it. So when I was young, I witnessed the power of solar energy in a couple of films. And these films gave me an inspiration for my academic career, such as this one.
You need the sun. Watch that mushroom-shaped rock. Ingenious, isn't it?
The panels lock onto the sun and then track it automatically.
Something like that, yes.
Reflected through this, those panels must produce a heat of at least 3,500 degrees Fahrenheit.
If you say so, Mr. Barton. But I do know that we can focus the power wherever we want. Over here, I'll show you. This is a bonus. Goes with the Solex. No extra charge. This is the part I really like. Now that's what I call solar power.
This is what I call solar power. And probably now you ask, was he inspired by these bad guys? Of course not. On the contrary. These films inspired me to look for an answer for this simple question. Can we build a device that can use the solar energy, not for these bad things, but for good purposes for people? And fortunately, and I was privileged to work on such a device. And this device is called a solar cell. And this solar cell now can pick up part of the enormous energy coming from the sun and provide electricity to these people. And during my research, at the beginning, I thought research on these solar cells is more or less an exotic hobby. But there was a moment that I realized this miracle, this solar cell, can really change the world. And by that moment, I really had my dream. Make the sun the donor of life on this earth, energy source of reliable, sustainable, affordable electricity for everyone in the world. And when we succeed in doing it, I believe that electricity will become a fuel for almost everything that we do on our earth. And when you realize that solar cells already today are changing the world of energy, are turning upside down, then you start thinking, okay, how the world will change with solar cells? Will it get better? Or what do we have to do to get it better? And step by step, by thinking about these thoughts, I realized that I have my mission. And the mission was building a world in which the inexhaustible energy of sun is available to all people in a useful form of electricity. Now we have the solar cells, we have solar modules, we call it photovoltaic technology, and photovoltaic technology has become a key part of so-called energy transition. And energy transition is a huge, very complex challenge. And we really need almost everyone to contribute to the success of the energy transition. And we should start with the youngest generation and spark curiosity and interest for the components and technology for the energy transition. And it is possible. Let's watch.
A ako ty robíš tú elektriku zo slnka? Ty máš taký rebrík hore, čo ide do neba?
You see that even Anička, when she was 4 years old, 2 years ago, was already interested how we make solar electricity. I use this drawing to explain how the photovoltaic technology works. We have the source, that is the sun. The carrier of the energy is solar radiation. And when the solar radiation incidents on a module, at the electrodes of the module, we measure electrical potential. So, when we have a bright day, like it was yesterday, not today, the sun delivers via solar radiation about 1,000 watt per square meter. When we have a module that has 1 square meter and the efficiency of 20%, then the electricity that the module delivers is in 200 watts. Now, actually, it is a solar cell, so that is the engine of PV technology. And so let's have a look inside the solar cell. So this is the solar cell. And the most important of a solar cell is a semiconductor material which absorbs light, and where in this material the electrically charged particles are created. And we need these electrical charges to carry electricity. These are electrons, and in semiconductor materials, the positive charged particle is a hole. And to finish a solar cell, we need a stack of so-called supporting layers. And when we want to connect solar cell to the external world, we have to apply electrodes, the front and back electrode, or positive or negative electrode. Well, so when you look at the solar cell, you can immediately get a feeling what to do to get solar cell very efficient. So actually what you have to do is maximize absorption in the semiconductor absorber, which leads to the generation of electrical particles. and then take care that these photo-generated electrical particles are not lost. So in other words, we call this process recombination of these electrical particles. And this simple approach was also a guideline during my research career. And my question was, how can I apply physics and material science to make the solar cells better, to make their performance higher? Well, about my steps in the career was a lot of said already in the introduction. So I started here in Bratislava. I studied at Technical University in Bratislava at the Faculty of Electrical Engineering, and my specialty was material sciences. And I work on this special material, amorphous silicon, also during my PhD research. And as you can see, the amorphous silicon is different than crystalline silicon in that way that in crystalline silicon, the silicon atoms are very nicely, orderly connected with each other, and in amorphous silicon, this order is disturbed. But at the time, 30 years ago, when I was looking at this material, amorphous silicon was very attractive material for many purposes, and one of them was solar cell. And it is this material that I have had such a fruitful cooperation with the Slovak Academy of Sciences, which was mentioned in the introduction. We really work together to learn about the properties of this amorphous silicon, because when you want to optimize a solar cell, you really need to know all the details about the materials that you use to build up a solar cell. And thanks to very special measurement techniques that were developed at the Academy of Sciences, we could really learn a lot about the properties, especially the electronic properties of this material, and also looking on the ways how to improve this material to make high-efficient solar cells. Well, after finishing my PhD, I got an golden opportunity for a half-year postdoc position at the Delft University of Technology. And from this half a year, it is now 34 years that I am active at this university. And I would like to acknowledge Delft University of Technology for the support for my career, that I could really work on development of solar cells, photovoltaic technology in general, and also deployment of this technology in electricity grid. As it was mentioned, around 2009, I was appointed a full professor, and I delivered what we call inaugural speech. And as a full professor, I could start building my team. My chair was called Photovoltaic Materials and Devices, shortly PVMD group. And this team could then work on the ideas that I presented during my inaugural speech. And during my inaugural speech, I already pledged the ambition that I would like to make my group, my team, a player in the global PV Champions League. And when you have this ambition, you really have to look at different aspects and work it out. And they are, think about the strategy of your group, what kind of team members you will have. Motivate your players that they really do teamwork, and at the end, to take care of technical support. And it is this technical support that is financially very demanding. I'm not going into detail of these all aspects, just to strategy from the scientific point of view. I really decided that we would work on silicon-based solar cells because, to understand, there are many semiconductor materials that are used to make solar cells, but silicon is the dominant one. And then, as I mentioned, I wanted to use physics, for example, optics, material sciences, to make the crystalline silicon and amorphous silicon solar cells better in their performance. And very important part of the activity is modeling of the performance of these solar cells. I will show you my heroes. These are my PhD students that were doing wonderful work. They delivered the great results that made the team really a top player in the PV international arena. One of the most successful PhD students was Hiren Tan. The PhD students were working on developing all kinds of thin layers of various materials, developing the light management concepts to get as much light possible in the solar cell. And once we thought we have a good base of these concepts and materials, we decided, okay, let's now make a solar cell that will have a world record efficiency. And we asked Hiren Tan to lead a team, we call it a Sky team. It was also a team of other PhD students in the room to make such a world record solar cell. And Hiren and his team did it. They made a tandem thin film silicon solar cells based on amorphous silicon and microcrystalline silicon with the world record initial efficiency of, as was mentioned, almost 15%. And you can imagine that this was our entry to be a top team and playing the Champions League. Maybe something more about Hiren, because it's a very nice story. After finishing PhD, he went to Canada for 2 years postdoc. Now he is back in China, a full professor at Nanjing University. And 2 years ago, he started his own company to produce what was mentioned today, a very perspective material, perovskite solar cells. In 1 year, the factory was built. In February, operational. The modules are coming out of the factory, and now these perovskite modules, big modules, are in certification process. And he visited me in June or July in Bratislava and brought this perovskite module. As you can see, it's more or less a multifunctional product. You see that even with this light, the module powers the LED lights, and on the front of the module is a pattern, so this is already very nice for some aesthetical applications. So in Europe, we are busy with very small perovskite solar cells to demonstrate their efficiency. In China, they are already making big modules. This is just to give an impression how quickly things can go in China. The best crystalline silicon solar cells are based on an approach that we call heterojunction solar cell structure. And my PhD student, Yifeng Zhao, optimized the solar cell structure, and at the end, he fabricated a solar cell with almost 24% efficiency, which is the best crystalline silicon solar cell fabricated in the Netherlands. There is a limit to obtain conversion efficiency with a solar cell that has just one of these absorber layers. And this limit of efficiency is around 30%. Our ambition is to go above this limit. And how you can do it, you can take different solar cells, different that way that the absorber material is different, so that different absorber materials effectively use different parts of solar spectrum, and when we put them on top of each other, we can use larger part of the energy of solar spectrum. Again, you see Yifeng Zhao with his heterojunction crystalline silicon solar cell, and colleagues from Eindhoven University and TNO Institute in the Netherlands. We made together a tandem crystalline silicon perovskite solar cell with efficiency about 30%. It was 2 years ago, and at that time, this was the best world performance. And we showed it at the World Conference of Photovoltaics in Milan. To facilitate the new research trend in photovoltaics, and it is this trend towards tandem solar cells, high efficiencies, and also facilitate Dutch and European companies to start solar cell production in Europe, we established 3 years ago TU Delft PV Technology Center. And in the clean room, we have 2 fabrication lines, one for fabricating crystalline silicon solar cells. The second is for perovskite solar cells. And we believe that in the near future, at the Delft University of Technology, we can make these high-efficient tandem solar cells. In some next slides, I would like to show what is the real status of the technology. And I will show you the best efficiencies in the world of the solar cells, then how we installed PV systems, and also what is the price of the modules. This is probably most interesting for many people. So, in 2022, so 2 years ago, this Chinese company, Longi, introduced a solar cell with the world record efficiency, 26.8%. In our laboratory, maybe you still remember, it's 24. But why I am showing this is that they published this result in Nature journal, which is one of the best cited journal, and co-author in this work was my group, Photovoltaic Materials and Devices. The part that we contributed was modeling. You know, in companies, they do not have time to really understand all the details of how the processes within solar cells are doing. This is what we can provide for these companies by modeling. And you see, this year in May 2024, the same company showed a new world record, which is 27.3%. And when you realize that the theoretical limit of efficiency for this type of solar cell is 29.4%, we are very close to really a theoretical limit. In my group, we still work on new architectures for this type of solar cells and model what can be the performance, and we find out that there are still possibilities to improve the cell, coming to more than 28%. And I believe that one of these big Chinese companies will soon show this result following our modeling work. And back to the tandem, crystalline silicon with perovskite, the same company, Longi, in June 2024, a couple months ago, announced the world new record, 33.6% efficiency. Now, how we installed PV systems. In 2022, the PV world achieved great milestone. And this great milestone is that we installed cumulatively capacity to generate electricity more than 1,000 gigawatt. We call it, we entered so-called terawatt era. You see also some numbers, but I can imagine that when I finish with my address, you don't remember the address, the numbers anymore. So to give you a feeling what we talk about is, I take as an example one and only at this moment nuclear power plant in the Netherlands. We call it Borssele Nuclear Power Plant. Borssele Nuclear Power Plant has a production capacity about half of what we have in Jaslovsky Bohunice. It means about 0.5 gigawatt. And this nuclear power plant, when it's in operation, it delivers between 3 to 4 terawatt hours energy per year. And now when you look at this number, in 2023, the cumulative installed capacity of PV systems was this 1,412 gigawatt peaks. But what is important, they delivered this amount of electricity, 1,630 terawatts. And when we calculate how many Borssele nuclear power plants you need to deliver this electricity, it is 390 nuclear power plants. Do you have an idea how many nuclear power plants are now in the world in operation? 300. Just to save time, 440. Yeah, so we are very close. And when you realize that only in 2023, we added 400 gigawatt capacity, which corresponds to 100 nuclear power plants of Borssele in 1 year in the world. In 2023, we more or less adequately built 100 nuclear power plants. And when you imagine that to build a new power plant, it takes, in ideal case, 10 to 15 years and can be extremely expensive, PV technology is really a nice option to deliver electricity. Of course, I would like to show you also how PV is installed in the Netherlands, where I am active in Slovakia. In the Netherlands, you see last year's, it's unbelievable boom to install PV systems. And in Slovakia, in last 10 years, more or less, we stayed at the same level. Maybe last year, there are a couple of new systems installed. So, the PV systems in the Netherlands last year delivered electricity corresponding to 5 to 6 plants. In Slovakia, it's 1/3, 1/4 of the capacity of a nuclear power plant. And what is interesting to also show that in the Netherlands, last 4 years, each year, we added such an amount of PV systems that they deliver electricity again, that delivers electricity of the nuclear plant. So last 4 years, we added capacity of 4 nuclear power plants. I will be only happy to help in Slovakia how we can facilitate the implementation of photovoltaics. And now about the price. You see the first PV modules were introduced in 1976. The price of the watt peak, so the power that can module deliver, was $100. $100. Last year, at the end of the year, the price of the watt peak was 10 cents. So in 50 years, less than 50 years, the price of these modules has decreased 1,000 times. It's incredible. And this will continue. And it means that when we look at 1 square meter, solar module is one of the cheapest products. Yeah? Square meter is about 20 to 30 euros. When you want to have your wooden floor in house, this costs 50 to 100 euros. When you want such a nice glass home, it will be 100 to 150 euros per square meter. I'm not talking about this screen. Maybe 1 square meter of this screen is 1,000 euros. This has become the cheapest product per square meter that you can buy. Now, the future. We still have a lot to do. But this study shows that it's a good news for photovoltaic technology. And actually what they show is what is the cost of electricity. So not of a module, what I showed in the last slide, but electricity. And this is what the consumer is interested most in. How much I have to pay for 1 kilowatt hour that I use. And this study, executed by universities of Exeter, Cambridge, College of London, and the World Bank, shows that 3 years ago, still in many parts of the world, the cheapest electricity came from wind energy and wind turbines installed on land. But you see that the trend is, according to this study, that PV will deliver the cheapest electricity in 7 years all over the world. And you see the prices of the electricity. So depending on the location, the price of the solar electricity was between 2.5 to 9 cents per kilowatt hour. And when you compare it to what we pay today to the utility companies, which is, I think, 30 to 40 cents per kilowatt hour, so this is really the best investment that you can do to save money on electricity. And the prediction is that in 2030, the price of the electricity will be less than 1 cent of kilowatt hour. Still a lot of work to do, and there are also challenges, and the challenges are social acceptance, then political barriers, technological challenges, as I mentioned, and many others. And they depend on the technology. So this is what we work on in the future, on the modules, high efficiency, flexible in size so that we can put it everywhere in facades, invisible modules, intelligent and circular. At this moment, there are 4 billion modules already installed, 4 billion. When you imagine that we have 1.4 billion cars, so this can be an enormous waste, so we have to work on it. And we want to put the PV on every suitable square meter, and you can see different applications where we already tried to do that. Just something about education. I mentioned the PV is the key for energy transition, and we really need everybody to be active and get education on these new components and technologies. And we have a master program at Delft University where we look at these different technologies and learn students what have to be done in the future. My group, PVMD group, was about the pioneers to introduce also online education so that not only people, students at the campus, but all over the world can follow the education. And my colleague Arno Smets introduced the solar energy online course, so 10 years ago. In the first edition that year, he had 60,000 students, 60,000. So now, after 10 years, it's probably 1 million. So everybody in the world who is familiar with PV technology knows this guy. And whenever he goes, everybody wants to have a selfie with him. So I am sure that he is on the most selfies on the world. And you see, these are the examples of the courses that we developed, and we also wrote a book to facilitate our students on education on solar energy. And also an educational laboratory where our students can confront their theoretical knowledge with the practical exercises. My last slide is about what is the future. And what you see here was an announcement of an exhibition on energy in the Museum of Modern Art in New York. And what do you see? When I look at it, it was clear that the message is we still need fire to get useful energy, like electricity or heat for cooking. And it was mentioned already by Professor Samuelyho. When we look at the logo of our university, do you have an idea what the symbol is? It's the flame of Prometheus, the god that stole the fire on Olympus, brought it to people. So for thousands of years, we are using this technology of burning fossil fuels. But now we are at the moment we really have to switch. We really have to change the technologies. We really have to switch to primary energy sources where the burning technology is not applicable. And because this is the core of energy transition, we really need everybody, and it affects everybody, so it is also our shared obligation. And we are already at the moment that we can dare and must change the primary energy sources. And when everybody of us contribute its part, then I dare to say that in 20 years we can say to our children and grandchildren that we succeeded, we did our job and got the energy transition done. Thank you very much.
Thank you very much again for a great and, I dare to say, very inspiring talk. Now, on behalf of the President of the Slovak Academy of Sciences, Professor Pavla Šajgalík, I would like to extend our thanks to all of you for coming and attending the ceremony, to the artists for the marvelous performances, and of course, especially to the award recipient himself. Ladies and gentlemen, thank you. And now please rise for the procession of the Slovak Academy of Sciences.